First, I want to introduce my group member and also my friend. That the first one is group leader, Siti Nurnajiha binti Muhammad. The student ID is 2023213564. And the second one is Vincent Angel Young, and the student ID is 2023829398. And the third one is Muhammad Hifzul Iman bin Shahrul Fitri, and the student ID is 2023485042. The fourth one is Muhammad Afif Fawaz bin Yusri Rizal. The student ID is 2023610668. And the last one is me, Muhammad Faris Faik bin Muhammad Faizan, and the student ID is 2023639248. The first thing that you guys need to know in this video is what is related rates.
Related rate problem deal with two or more variables that change simultaneously, potentially at different rates. By understanding the relationship between the variable and the rate at which one of them is changing, we can determine the rate of change of the other. This process typically involves establishing an equation that connects the variables and differentiating it with respect to time, often use implicit differentiation.
And now we can go to how to solve related rates. Problem statement. And the given problem statement is an ice cube in the shape of a cylinder is melting at a constant rate of 5 cm cubed per second. And the surface area of a cylinder is equal to 2 pi r square plus 2 pi r h. And the h is height. Volume of cylinder is equal to pi r square h. First question is find the surface area of the ice cube in terms of r. Second question is find the volume of the ice cube in terms of r. And the last question is find the rate of change of the surface area of the ice cube when the radius is 10 cm. We go to solution of question A and B. Question A, we can use the surface area formula of cylinder is area equal to 2 pi r square plus 2 pi r h. And the h is I. And as you guys can see at the previous slide, we can see that height is given r plus 5. And we need to substitute the r plus 5 into h. And the next equation is 2 pi r square plus 2 pi r open bracket r plus 5 close bracket. The next equation is 2 pi r square plus 2 pi r square plus 10 pi r. And the last equation is 4 pi r square plus 10 pi r. We move to question B. Volume equal to pi r square h. And same as before, we need to substitute the height that given is r plus 5. And the equation can be pi r square open bracket r plus 5 close bracket, and the last answer is pi r cubed plus 5 pi r square.
Okay, next we'll go into the question C. So dv over dt is given negative 5 centimeters cube per second, and we have to find out what is dA over dt when the radius given is 10 centimeter. So dA over dt equation can be shown as dA over dv times dv over dt. So dA over dt, we'll substitute the dr into it. So dA over dr times with dr over dv times with dv over dt. That will give us dA over dt. So next we have the value of A, the area, and the volume, dA over dr and dv over dt. So the value of A is 4 pi r squared plus 10 pi r. The volume is pi r cubed plus 5 pi r squared. dA over dr is 8 pi r plus 10 pi. dV over dt is 3 pi r squared plus 10 pi r. So we can find dA over dt with this equation, that is 8 pi r plus 10 pi times with 1 over 3 r squared plus 10 pi r times with negative 5. We will get the equation negative 40 pi r minus 50 pi over 3 pi r squared plus 10 pi r. So when the radius is given 10, we'll substitute into the equation, that is dA over dt equals to negative 40 pi. Substitute the radius into it and we'll get 10, that minus with 50 pi over 3 pi times with 10 square plus 10 pi multiplied by 10. We will get the answer negative 450 pi over 400 pi. We will simplify it into the negative 9 over 8 centimeters squared per second. That will be the final answer.
In conclusion, related rates provide a methodical approach to analyzing how interconnected variables change over time. By leveraging equations that describe their relationship by applying implicit differentiation, we can solve for unknown rates of change. This technique serves as fundamental tools in calculus, with a broad application across science, engineering, and real-world scenarios.